And now we're going to go through one final practice. One last hurrah. The end is near. So we have a practice test, and it will probably be highly similar to the real test, which means that if we can do well on these questions, we'll do well on the exam. And that's good for us. We like it. So make sure you put in the practice and help yourself succeed. Now, as you're doing this test, also remember to have your tools ready. When I'm talking about your tools, I mean a calculator. You will need a calculator on this test if you want to do great. Without a calculator, you can still do well, but we want to do great. So make sure you have it, know how to use it. All right, well, we should get going. We have 22 questions, plenty of time to work on things. Quick question number 1, true or false? This is a practice exam, and as such, the questions will be different from what will appear on the actual exam. That is true, right? This isn't the exam. It is practice. But that being said, it will be different from, but probably very similar to. Okay? So let's be realistic here. You control your own destiny. If you can do these problems and are able to say, look, I know the procedure, you're going to do well on the actual exam. All right, now let's get to the real meat. Number 2, solve. You have 15 plus 3y less than or equal to 6 times y minus 4. Simplify your answer, give as an integer or a fraction. Now, what's going on here? When it talks for solve, the idea of solving when you have an equation where there's one variable means really you want to get y by itself. So, okay, so that's what we mean by solve. Get the variable by itself. All right, well, now that we understand our goal, we say, okay, what do we do? Well, let's start by doing expansion, right? Because I have this 6 times parenthesis y minus 4. So we're going to distribute the 6 through. And it distributes into both the terms, right? Not just the first term, into all the pieces. So that's less than or equal to 6y minus 24. Now we say, okay, we'll move things around. So I can move the 6y across, and I can move the 15 across. And if we do that, 3y subtract 6y, so we move things across by subtraction, would give us negative 3y. And here, we'd subtract 15. Negative 24 subtract 15 would be negative 39. All right, now what? Well, now we can divide. In this case, we divide by negative 3, right? Because we want to just get y, not negative 3 times y. So divide both sides by negative 3. Now, be careful. Sometimes you have an inequality and you don't need to worry. When there's an inequality, it's just expand, gather, and then divide out as needed. When you have an inequality, if you divide by a positive, keep it as is. If you divide by a negative, fix it. So how do you fix it? Well, you say, look, you flip the direction. So the negative 3 is canceled. We flip because of the division by negative. 39 over 3 becomes 13. And there you go. Now, how do you check it? Well, one thing is if you plug in 13, you should actually get equality. And here, 15 plus 3 times 13, well, that's 15 plus 39, and that's 54. 13 minus 4 is 9. 9 times 6 is 54. So cool, you got equality when you've got equality here. And if you pick a number bigger than 13, something like, well, let's say 20. 15 plus 60, and compare that to 6 times 16. Well, yeah, the inequality is true. So that's good. All right, we can solve inequalities. Number 3. Consider the 2 points, all right? And specifically, these 2 points. And what are we asked to do? Well, it's crammed in here because there's a lot. It looks like we're asked to find. I'm going to highlight these points here. So find the slope of the line that passes through the given points. And select the correct choice below, and if necessary, fill in the answer box to complete your choice. All right, slope. So slope, we use M. M for slope. Why? Well, we ran out of letters. It's not like melope. No, slope. Okay, but how do we do it? Well, the idea here is what? Slope, which we write as M, it's how much you change in the y's. We often call that the rise, over how much you change in the x. And we often call it the run, rise over run. So for us, we say, okay, let's do this. So we say take negative 15, which is the y, subtract negative 6, and divide by 2, which is the x, subtract negative 4. Change in y, change in x. And, well, okay, so negative 15 minus 6, that's negative 15 plus 6. That would give us negative 9. 2 minus 4, that's 2 plus 4, that would be 6. Now, notice here it says simplified fraction. Simplified says make sure you get rid of any common terms. Well, it turns out 9 and 6 have something in common. They're both divisible by 3. So if you divide out by the 3, we end up with minus 3 over 2. So M is minus 3 over 2. All right, so that's part A. So we have to select it. This is our answer. The slope is not defined, is not true. When does the slope is not defined happen? That's if you have a vertical line. And so if your x values were the same, that's slope not defined. And slope not defined happens because you have a divide by 0 situation. All right, so let's look at part B. The standard form, not the standard from, classic typo. The standard form of the equation of the line is blank. And use integers or fractions for any numbers in the equation. Now, before I actually do that one, let me peek ahead. Part C. What is the equation of the line in slope-intercept form? And select the correct choice below, and if necessary, fill in the answer box to complete your choice. So we're talking about different forms. So how do we distinguish these? Well, let's make a quick note here, and once we have that, we'll have a pretty good idea of how to proceed. So standard, that says we're looking for ax plus by equals c. Everything can be written like that. Even the vertical lines can be written like that. Slope-intercept, which is down here, slope-intercept, well, what does that look like? That's y equals mx plus b. This can't handle vertical lines, but it can handle anything else. Now, the good news is, for slope-intercepts, we already have m, because we found it in part A, so we're kind of halfway there, but we don't know b. So how do we proceed? There's a couple of ways to do this, but here's what I like to do. And if you go back to the idea of the slope, let me give myself some space here. So if you think about what's going on here, you have the change in y over change in x. So what we can write this as is y minus a y coordinate over x minus an x coordinate is m. Or y minus a y coordinate is m times x minus an x coordinate. Okay, so that just says take the slope equation and rearrange. But we know slope. And we know points. In fact, we know two of them. We can pick either one. Let's suppose we pick this one. Y minus the y value would give us y plus 6 is equal to m, which is minus 3 halves, x minus the x value. Well, x minus minus 4 is x plus 4. Well, that's y plus 6 is equal to minus 3 halves. And then here, we're going to get minus 3 halves times 4. Well, if you take minus 3 halves times 4, what do you get? Well, you're going to get minus 12 halves, or minus 6. And now, like, aha, slope-intercept form, subtract 6 from both sides. And that gives us that y. Whoops, I don't need to put a y equals, because that's already there. Ha ha ha. Classic mistake. A lot of people do that. And so, if you see a y equals, say, look, I don't need to do y equals. I just have to put in what the other side would be. So you get the minus 3 halves x. Bring that 6 across by subtracting. Minus 6 makes minus 12. And now we can jump back. Okay, so given that we have y equals minus 3 halves x minus 12, if we add 3 halves x to both sides, that says y plus 3 halves x equals minus 12. And that's the standard form. Now, I will say standard form is not quite unique, because you could do things like scale. So, for instance, if I multiply everything by 2, 2y plus 3x equals minus 24. And I guess I should usually write the x first by convention. But, there's lots of ways to do it. So you have here 3x plus 2y equals minus 24. And you can check your work by just saying, well, plug in points. Minus 12 gives minus 24. 6 minus 30 is minus 24. So it doesn't hurt to check yourselves. As the great mathematical philosophers will always tell you, you should check yourself before you wreck yourself, right? Absolutely, because what do we want? We want the points. And when do we want them? When we take the final, right? Right. All right, good. Number 4, complete the square and find the vertex form of the quadratic function. Okay, so let's talk about what is vertex form. So vertex form is saying, if you think about a parabola, there's this bottom out point, right? There's this bottom piece of the parabola. So that is, if you were to draw it, there's this parabola. This point right here, this is what we call the vertex. So now, what's the goal? The goal is to help us identify that very easily. So vertex form says you want to have something that looks like y equals some constant c, x minus a squared plus b. And what happens is that your vertex is a comma b. All right, that's the punchline. Now, for us, we don't actually need to know that the vertex is a, b. The point here is this is what's meant by vertex form. So how do we get there? Well, it kind of tells you how to get there. It's telling you a direction. You're going to do a complete the square. So this is a complete the square type problem. So you begin by saying, all right, if I want to do a complete the square, I start by saying I have this x squared, and I would say, what's in front of it? Well, it's 1. I'm like, yes, that is what I like. I like there's a 1 in front of it. That's cool. And then I put a minus 6x. And now I pause. And I say, okay, don't worry about the plus 11 second. Put that aside for now. We're going to come back to it. We're not forgetting it, but we're going to pause. You say, all right, what do we need? Well, what we do is we take the middle term. Okay, so first off, let's do a quick reminder. Make sure this is a 1. And usually, for these types of problems, say, make it a 1. If it's not a 1, just factor it out. Do whatever. Make it a 1. You can divide both sides for what's in front for just a moment. Whatever you have, make sure that's the 1. Now, here's the procedure. You're going to take what's in front of here, and first you divide by 2, and then you square it. So negative 6 divided by 2, negative 3. Square it, 9. So you say, if whatever you get here, that's what you need to put there. Okay? So this is the complete the square part. So at this moment in time, we say, hey, this part right here is nice. But we have to come back and say, well, wait a second, we had a plus 11. What do we have? Well, because there's a 1 here, we have a plus 9. We say, well, gosh, how do we turn a plus 11 into a plus 9? Or rather, more precisely, how do I get this plus 9 back to a plus 11? What's short? Well, what's short is we're off by 2, so we need to add 2. 9 plus 2 to get 11. And now, what's the punchline? We say, because of what we added here, this becomes x minus 3 squared. Notice that this minus 3 is the same thing that you get by dividing by 2. Not a coinky-dinky. That's meant to happen. And then we still have this plus 2 on the end. And that's vertex form. So we put that in, x minus 3 squared plus 2, and then we're like, woohoo, yeah! And because we're done with that problem. And so let's not dwell. We go on to number 5. Find x in the following equation. I found it. Oh, wait, no, that's not what it meant. Okay, it means, we got to solve for the value for x. And here, what do we see? We see logs. Now, logs have wonderful properties. Quick reminder, what do we have? Well, one thing is we can say log base b of, I'll say st, is log base b of s plus log base b of t. That is to say, if you have multiplication on the inside, it comes apart as addition. Or, if you have addition, it pushes together to multiplication. Now that's the one we need. Okay, so I'm going to put a little box here just to remind us that this is our useful one. But while we're here going down memory lane, we might as well remind ourselves of how cool logs are. For example, division becomes subtraction. And if you have something to a power, s to the power t, the power comes out in front. So lots of great stuff happening with logs. So what's happening here? We have our addition. Addition becomes multiplication. So we say, okay, this is log b of x times x minus 7. That has to equal log base b of 18. Now, we say, oh, well, if I have log on both sides, so it's log base b of something equals log base b of something, then the moral is the somethings, I know that's a very technical term, but the somethings have to match. So we say, okay, set the somethings equal to each other. So we need x times x minus 7 to be 18. Or x squared minus 7x equals 18. We subtract, and we're like, all right, quadratic, nice. We can factor. We can use quadratic formulas. Now, I'm going to go on the belief that they want us to succeed, so highly likely at factors. So don't stress out and be like, oh, I got to use the quadratic formula. No, try to factor if you can. If you're not comfortable, quadratic formula is still there. And how do I think about factoring? Well, I say, well, I need two numbers that would multiply together to give negative 18, but would add together to give negative 7. It's not too hard to think of two numbers that would do that. Well, 9 and 2 multiply to 18, and I need there, to have one be negative, one be positive. And since it's a negative 7, I better make the larger one negative. So this suggests x minus 9, x plus 2. And you can check, right? X squared, good. 2x minus 9x, also good because that's negative 7x, and then negative 18. Now, this says there's two solutions, right? Because 0 is a friend. And one of the things about 0 is it says if you have two things multiplying to 0, one of them has to be 0. So this says, oh, lo and behold, we get that either x minus 9 equals 0, or we get x plus 2 equals 0. So that says x equals 9, or x equals negative 2. So it's like, oh, that means there's two solutions, right? Be careful, because there's one other thing to add. Now, there's actually many things we could add, but as it relates to this problem, there's one other important fact. When you put something into a log, this part needs to be positive. If it's negative, you can't plug it in. It's just not going to work. Would not be prudent. Don't do it. Now, why do I point this out? Log of negative 2, forget it. Hopeless. Hopeless. If you put it into your calculator will go, ah! Unless it's a very expensive calculator, then it will say, which is a different story altogether. It gets, well, complex. But okay, the punchline is, can't put a negative in, which means you can't have the solution x equals negative 2. That's out as a solution. It's not just randomly out. It's, there's a reason why it's out. Can't take logs of negatives. But what does that leave us with? It leaves us with possibly 9. You can check. That's 9. That's 2. In both cases, we're good to go. So our final answer, just one answer, 9. And that's number 5. All right. We're doing great. On to number 6. If $5,000 is invested at 3%, compounded quarterly, what is the amount after 10 years? Well, the amount after 10 years will be something. And we're told to round to the nearest cent. Okay, so how do we figure this out? Well, there's a generic formula here. That is to say that our amount here, so that's what we're trying to solve for. That's our initial amount, our present value, or principal, whatever you want to call it. And then there's interest rate. So there's a couple of formulas we had. I'm going to write this as 1 plus I to the n. I'm going to explain where these pieces come from. So let's, I'm going to change colors here. And so we have that the P, that's the initial, and the N, this is the number of times we compound. And then the I is the interest rate as decimal, this will be important, per period. Okay, so some of these are pretty quick. The initial, that's pretty clear. We said, oh, we're starting with 5,000. Okay, so we have 5,000. So this is 5,000. So this is our initial, 5,000. Now, we have 10 years. So does that mean n is 10? No, because we're compounded quarterly. So what does that mean? Well, it means every year we compound 4 times. So we have 10 years, we compound 4 times per year. So here, n is 40. So we're going to have something, 1 plus something to the 40. Now, what's the interest rate? Well, first off, you have to put it as a decimal. So 3% as decimal is 0.03, right? Just move the decimal place. But that's not the whole story. Because 3% is what you get over the course of a year. However, we're breaking it up and doing it 4 times. So 0.03 over 4, right? This is the interest rate, that 3%, but because we're doing it quarterly, every quarter we don't get 3%. Every quarter we get 1/4 of 3%. All right, and that's the computation that we have to make. Now at that point, we say, hey, we've got our trusty friend. And so, come on, trusty friend, don't let us down. We clear off our computation, and we say, all right, we have 5,000, and then we're going to times it by, parenthesis, 1 plus 0.03 divided by 4, right? Double check. Is it being entered in correctly? Parenthesis. Caret, that means raise it to a power of 40, and hit the equals, and we get, as an answer, $6,741. Remember, rounding to the nearest cent, and so that would be 74 cents. Okay. Now, for these types of questions, you should always ask yourself, is this reasonable? Well, good question. If we take 3% of 5,000, what do we get? $150. So even if we didn't have any compound interest, right, interest on interest, 3% is, in 1 year is 150. If you multiply it by 10, that's like 1,500. So we should have 6,500 plus a little bit. So this is a reasonable answer. If we got like 20,000, it's like, whoa, wait a second. That's too good to be true. Or if we got something below 5,000, like, wait, hold on. How can I make an investment and lose money? That's not how interest works. So don't just blindly put a number in. There's a reason why these numbers work, and they should work as you expect, right? Use your experience and your knowledge. It's good for something, right? We don't go through life to get experiences and not use them. All right, so anyways, that's your basic formula. Make sure you know that one. It's not too bad. And when you just think about what's happening, it's like, how many times do you compound? Well, number of years times number of times per year, that's n. And how much do you get every time? 1 plus, this I. All right, that brings us to number 7. Okay, solve the following problem. We have lots of symbols, and we're like, wait, what problem is this? Well, we have our present value. That's what PV stands for. So this is the present value of, whoops, I don't know why there's this rogue L, excuse me. So $31,805. We have the number of times. We have the interest rate per time, so I is interest. And then PMT, this is payment. And so essentially what's happening is we're talking about the following. We're going to get some money every time for 60 times. And over time, and we're saying, okay, what's the present value of that going to be? So in essence, it's like the present value is I'm taking out a loan of $31,805. And what I want to figure out is, okay, if I'm going to pay that back over 60 intervals, and for each interval I have this interest rate, what's the current payment going to be? All right, so how do we find that? Well, good news, there's a formula. Bad news, you have to remember it. This is not one of those ones that is just going to roll off the tongue. And so you're going to have to store this. I don't have any it's going to be So start practicing this. So here you go. I'll write in this way. The present value is, you figure out how much are you paying each time. That's your payment. And then what's really happening is you have what we call the geometric sum. And the nice thing is, because you have a geometric sum, you're able to collapse it. And it turns out that this becomes 1 minus 1 plus I to the minus n over I. Okay, so that's the formula. So this you have to know somehow. And so, all right, use some practice. Write it down on some note cards. Write down 10 times. Whatever it takes, Keep writing it down over and over and over again until you can do it. With that out of the way, what do? Well, it's like, I know all these pieces except for this one thing, and that's what I'm trying to find. And so at that point, you say, oh, put in what you don't know. Sorry, put in what you know, solve for what you don't. Now, before I actually get there, we'll go ahead and move this across. And so our real formula, as we rewrite it, so that says payment is the present value times I over 1 minus 1 plus I to the minus n. And so for us, that would be 31,805 times 0.025. Right, that's our I over 1 minus 1 plus 0.025 to the minus 60. Okay. Well, that's the computation. So we pull out again our calculator. Whoa! It's good to have one. 31805 times 0.025. All right, so there we go. 31805 times 0.025. Divide by parenthesis. Parentheses are your friend. 1 minus, again, all right, parenthesis, 1 plus 0.025. And, be careful. See, I forgot to put the 2 in there. So double check. Now, don't go so fast that you miss out on stuff. To the, and I'll put this as negative 60. Okay, good. Another parenthesis, and we should be good to go. What does that equal? And the answer is 1,028.999. Okay, well, what are we going to do? Round to 2 decimal places. So in other words, like we're rounding to the nearest cent. And very conveniently here, you look and say, oh, 0.999. Well, when you round to 2 decimal places, you're just going to round up to the nearest dollar. So our payment for this is going to be 1,029. That's it. Wow. Cool. It worked out, right? Yeah, right? If you know the formula, it works out. Now, what is this saying? It says you're going to make 60 payments of 1,029. So over time, you're making payments. So you're like, wait, I'm paying back $60,000, but I'm only getting 31,000 today. Well, unfortunately, that's sort of what happens, because this is a pretty high interest rate if you think about what's going on. And so it's like, look, sometimes you get charged a high interest rate, and so you're going to pay back more. And so one thing that should be true is if you think about, okay, n times number of payments should definitely be more than the present value, right? Because somehow it's like as we make lots of payments over time, the later payments aren't worth as much. All right, anyways, I'm rambling. Punchline is learn the formula. And once you know the formula, it becomes very quick. You put in everything except the one thing you need to solve for. All right, which brings us to number 8. Woo! And now we're transitioning. So we just did a couple of questions on financial math. Right. This is a stroll down memory lane. And now we're getting to matrices again. Okay, so write the solution of the linear system corresponding to the reduced augmented matrix. See that line there? That says it's an augmented matrix. Select the correct choice below and, if necessary, fill in the answer boxes to complete your choice. Okay, so there's a unique solution, there's an infinitely many solutions, and there's no solution. Now, how do we know no solution? Well, no solution is if you have 0, 0, 0 number. But 0, 0, 0, 0 says, oh, don't worry about that. Okay, cool. So this is a line that you can ignore. It doesn't really add anything. It says 0 equals 0. And that's always true. 0 does always equal 0. And now, what happens? Well, this is going to be in infinitely many solutions. And let me explain why. Think about in every row, there should be a first one, because reduced augmented matrix says every row that has anything that's non-zero, the first term will be a 1. So there's a row with a 1 there, and there's the first one there. Now, here's the secret. If there's a column which doesn't have one of those first ones, like, for example, this column, then this represents free choice. And that free choice says you have many solutions. Okay, so we are in the case when there are going to be infinitely many solutions. So we're in the B case. Now, how do we find it? Let's read off what this says. So you have an x1, x2, x3, and over here equals the number. So the first equation becomes 1x1, 0x2, and 5x3 equals minus 2. The second equation, 0x1 plus x2 minus 3x3 equals 7. So that's the system. And notice something here. We're told x3 equals 2. Simplify your answers, type expressions using t as the variable. So you say, oh, if x3 equals t, then this becomes what? x1 plus 5t equals minus 2. And x2 minus 3t equals 7. You move terms across. That says x1 is minus 2 minus 5t. x2 equals 7 plus 3t. And that's what goes into these slots. These slots. Got to be in the right position. Negative 2 minus 5t for x1 and 7 plus 3t for x2. And there's the answer. So actually, in terms of using an augmented matrix, they did all the hard part for us, which is they got us the augmented matrix. Our job was to interpret it. So here's, can you be an augmented matrix whisperer? Can you hear what it's trying to say? And if you can, then you're going to do great on this problem. All right. Number 9. Find AC if possible. And select the correct choice below. And if necessary, fill in the answer box to complete your choice. All right, so we have AC equals something, or the matrix AC is not defined. Now, here we're doing straight up multiplication. There's two operations we talked about, namely if you have addition, so if you have a matrix plus a matrix, then what needs to be true is that these things must be the same size. And if they're not, forget it, hopeless. If so, add entry-wise. All right, so that's great. Now that's for addition. What happens for multiplication? Well, what happens is the following. If you have a P times Q matrix and a Q times R, I've written this very suggestively. The number of columns in the first has to equal the number of rows in the second. So these must align. So they do, right? So if these match, then we can multiply. But how do we actually do it? Well, this is where it gets a little bit interesting. The idea is we're going to go along a row in the first, down a column in a second. And we're just going to, so we're along a row, down a column. So, so this will make more sense when we do it. So let's just check. What is A? A has 2 rows, 3 columns. What is C? 3 rows, 3 columns. 3's match. So B is out. This can be done. So we actually need to do the multiplication. All right, well, let's do it. Okay, so here we go. So we're going to end up with, and by the way, what do you end up with? You're going to have this. It becomes a P by R. So for us, we're going to end up with a 2 by 3. So 3, 1, minus 2, 4 minus 6, 0. A 2, 2. I know how to write it, 2. Don't get ahead of yourself. 2, I'll go down columns. 2 minus 1, minus 3, 3, 5, 1, minus 1, 4, 6. Okay, so if I want the entry in the first row, first column, first row, first column, you multiply and then add 6 minus 1 plus 6, right? 6 minus 1 plus 6, 11. Okay, first row, second column. 9 plus 5 minus 2. So again, 9 plus 5 is 14, minus 2, 12. First row, third column. Minus 3 plus 4 minus 12. So minus 3 plus 4 is 1. Minus 12 is minus 11. Okay, halfway. Now, second row, first column, right? Row, column. 8 plus 6 and 0. Well, 8 plus 6 is 14, and add 0, well, it's still 14. 12 minus 30 plus 0. So 12 minus 30 is minus 18. Minus 4 minus 24 and 0. Minus 4 minus 24 is minus 28. Okay, and now what do we do? Oh, we just put that in. So we have our matrix, 11, 12, minus 11, and 14, minus 18, minus 28. And there we go. There we go. All right, and that's matrix multiplication. Number 10, graph the inequality. So here we have a nice grid given to us. We are told 3x plus 5y is greater than 30. So first off, where do we start? Well, we start by saying let's find some points, and I recommend find where you hit the axes. Those tend to be pretty simple points. So for instance, suppose I cover up the y for just a second. We get 3x and 30. When does 3x match 30? That's at x equals 10, which means we have this point, x equals 10, y equals 0. So that's a point that we're going to have for the line. Now cover up the x, 5y and 30. Okay, divide by 5. We get y equals 6. So here's another point. All right, so this is 0, 6. So these are 2 points on the line 3x plus 5y equals 30. Now, notice the type of inequality. This is a strict inequality. So it's not a greater than or equal to, it's just a greater than. So when it's a strict inequality, that means a greater than or a less than, the line becomes dotted. So once you have 2 points, then you dot the line between them, dot, 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 dot. And okay, so that's the part there. We have this line. But we're not done because it's an inequality. So when you have an inequality, you're going to shade one of these sides. So we need to figure out which side do we shade. And so test a point. So I find 0 to be a particularly easy point to test. Plug in 0, 0. 0 plus 0, is that bigger than 30? No, it is not. So 0, 0, the origin should not be shaded. So we pick the side which doesn't have the origin and say we need to shade that side. And I have a particularly good shading marker here. And so we're going to shade. Now, of course, if you're taking this on the computer, you have a nice little bucket that'll just, you click once and it fills in the whole thing. But, well, in a pinch, you use what you got. All right. So again, procedure, find some easy points. I like to find points on the axes. Use that to connect the line. Check the type of inequality. Is it dashed or solid? Test a point to figure out which side to shade in. And that's your graphing the inequality. You're done. You're done. All right. Number 11. This will be our halfway if we finish it. All right, let's see what we have. We are going to solve the linear programming problem. Okay, cool. So we're asked to maximize P, which is 25x plus 16y, subject to 3x plus 2y less than or equal to 18, xy greater than or equal to 0. Now, xy greater than or equal to 0 is a very common default type of requirement. It just says, hey, we want x and y to be non-negative. So we're in the first quadrant. So how do we proceed? Well, the good news is there's a fairly simple way to do it. So we're going to graph. We have our x, y. We know we're in the first quadrant, so I'm just in here. Here, let's focus on the line, and we'll think of it as just, doing what we just did in the last problem. Let's graph it. So we have 3x plus 2y equals 18. Well, imagine there wasn't an y there. We covered it up. Then 3x equals 18 would correspond to x equals 6. Cover up the x, 2y equals 18. That would correspond to 9. And now you play connect the dot. And so what you're going to get, particularly when you only have this one inequality, is you're going to get this triangle formed. Okay, well, we need to be inside the first quadrant, but 3x plus 2y less than or equal to 18. 0, 0 would be 0 plus 0 is less than or equal to 18. So that would say we do want to shade this part. Okay, so what we're asked to do is to say, okay, among all the points in this triangle, and there's a lot of points there, which one makes this expression small? Well, sounds hard, but then you remember, oh, actually, you just need to focus on the corners. That will give you your answer. And you might say, how do I know that? Look ahead. What are the coordinates of the corner point? So what are the corner points? A triangle has 3 corners. 0, 0, 0, 9, 6, 0. So we're going to make a little chart here. We have our points. We have our value for P. So we have the point 0, 0, 6, 0, 0, 9. And now, for each one of these points, we plug it in. 25 times 0 plus 16 times 0 gives us 0. Plug in 6, 0. 6 times 25, 150. 16 times 0 is 0, so 150. Plug in 0, 9. 25 times 0, 0. 16 times 9, 144. And by the way, if you're not comfortable, use your calculator. No shame. And now, here's the thing. You've made a list. You know one of these is the biggest. Which one? Well, 150 is bigger than 144. So our maximum is 150. So we do have a maximum. It's A. Now, B can be happen. If we had something where it was unbounded, it's possible. But because this is bounded, there's no way we're going to fail. So it's highly unlikely that B will be the right answer. Now, what are the coordinates of the corner point? Well, we've already figured out there is a maximum, so it's not B again. And so what we say, look, that corresponded to this corner down here. So the corner point that helps us maximize this is at 6, 0. And we give it as an ordered pair. And, we want to mark it. So that's A. All right, select the correct choice. A. And there you go. There you go. All right. And that, by the way, up to this point, and we're about halfway through the test, that's review. These problems were similar to ones that came on previous exams, which means that now we're ready for the new stuff. Okay, so the remaining 11 or so problems, that's what we've covered since the last exam. Okay, exciting times, exciting times. And I already see I have a typo here. I don't know why they put that there. There was an extra bracket. So 4P is 3, 6, 7, 8, 9. Q is 2, 5, 7, 11. And R is 1, 3, 5, 11. Okay, so we have 3 sets. These squiggly lines indicate collections of things. We call these sets. It says find this expression. Select the correct choice below and fill in the answer box within your choice. So it says, well, maybe there's something there, or maybe there's nothing there. So the empty set says there's nothing there. So let's make sure we understand what things are. There are symbols, right? Let's see what we have. So there's 2 main symbols here. We have what I call the cup, and this means the union, and this is also thought of as the or. Means it just has to be in one of the 2 things. Then what I call the cap, this stands for intersection, and I like to think of this as the and. So let's sort of dig into this. P union Q intersection R. And whenever you have parentheses, work within the parentheses first. So let's start with this. It says Q intersect R. So I have to be in Q and in R. So we start saying, okay, are there things common to both? Well, 2 is not common to both. 5, well, 5's there, okay. So 5 is common to both. 7 is not. 11 is. And now we can stop, right? Because if it's common to both, it has to be in Q. So I just check which things in Q are also in R. And the answer is 5 and 11. So that's Q intersect R. And now we union or combine, and we're going to do that. We have 3, 6, 7, 8, 9. And now we say, okay, it can be in either. And we say, okay, so we just start adding things in. So that would be, say, okay, certainly you get everything in the first set. And then you say, okay, is there anything new being added? And in this case, in both cases, both terms are new. Now, if it had happened that, oh, there was already a 5 there, I wouldn't need to add 5 twice. You just add it in once. It only needs to be put in once. So that's a small thing. But other than that, you just make a list. 3, 6, 7, 8, 9, 5, 11. We don't need to put in the squiggly brackets because those were already there. And so it's not empty. There's something on the inside. All right, so that's number 12. Oh, I like that problem. Maybe we'll get that on the test. Well, probably something very much like that will be on the test, right? That's sort of the point. All right, number 13. Refer to the Venn diagram. So the Venn diagram is where you have that 2 intersecting circles. So this is the Venn diagram. and find the indicated number of elements. Okay, so let's first off make sure we understand what we see here. U should be there. That stands for the universe. So here's the whole collection of objects. And we have two sets, this set A and this set B, and that breaks us up into 4 pieces. And now what you see is that there's a number inside of each piece. What do we do? Well, what we do is say, look, there are 17 elements that are just inside here. So that's in A, but not B. 25 in both A and B. 14 in B, but not in A. And 31, neither A or B. Okay, so it tells us the size of the individual pieces. Now we're after the number, n is a number, and we say, well, we want B intersect A, and then there's this apostrophe. So recall that A apostrophe, that's the complement of A. It's like, A, you're looking wonderful today. I'd really like to compliment you on how lovely you are. And you're always at the beginning. You always show up first. Good job for you. I appreciate your punctuality. Oh, wait, no, that's not what compliment means. This is a different kind of compliment. It means everything not in A. So we want to have things which are in B and, because it's an intersection, not in A. So we want to be in B, but we want to be not in A. So that's this piece. This is our B intersect A complement. So what's the number? Well, in this case, and mind you, you may have a slightly different scenario, but in this case, there's just a single number, 14. Sometimes you'll have an expression which might involve multiple pieces, and if that's the case, then you add the numbers up for the corresponding right things that are going to be counted. So figure out which pieces satisfy, this part, and then add up the corresponding numbers. And that's how we get our answer. All right. Good. Wow. That was pretty straightforward. Well, let's hope that keeps going. Number 14. A class of 40 music students includes 21 who play the piano, 29 who play the guitar. All right, a lot of people play the guitar. And 16 who play both the piano and the guitar. How many students in the class play neither instrument? Okay, so let's think about our picture. And for this, when I say picture, I really do mean picture. Venn diagram the situation. Okay, so we're going to go to a Venn diagram. And, all right, so we have our universe. And so we know that there are a total of 40 people. 40 students live in our universe. We have our 2 scenarios. And we have our piano players, and we have our guitar players. So we'll write P and G. All right, so let's see what we can say. We have 21 who play the piano, 29 who play the guitar, and 16 who play both the piano and the guitar. Let's start with this last one. It's the 16 who play both. Because the both is the intersection. So we say, because we can assign students to one of 4 possibilities. Only piano, only guitar, both piano and guitar, neither piano guitar. So the both tells us there's 16. Okay, now we know there's 21 people who play the piano. So there's a total of 21 people. 16 fall into here. So how do we get up to 21? Well, that means there need to be 5 people who play the piano but don't play the guitar, right? So if there's 16 here, and I need to get to 21, 16 plus 5. On the other hand, there's the guitar, right? I have 16 people here. And here, what do I have? Well, I have a total of 29 people who play guitar. 16 have been accounted for. How many people are left to be accounted for? Answer, 13. Okay, 16 plus 13 equals 29. Now, that says we filled in 3 of our 4 pieces. How many people have we accounted for? Well, we just add up here. And if we do that, we get a number. We get 34 students. So 34 students have been accounted for. But there are 40 students altogether. So that means there's 6 people who are not in here. So those 6 people don't play the piano or play the guitar. In other words, they're the students who play neither instrument. So the answer is 6. So essentially, you're just going through and sort of logically reducing. The Venn diagram can be very helpful here because it gives you a systematic way to visualize the process about what's going on. And so that's the problem. Oh, that was a fun one. All these problems are fun ones. Maybe we should take 2 finals, right? No. No. I know what's coming. I think we have something coming here. Okay. Oh, management selection. That's exciting. A corporation plans to fill 2 different positions for vice president. We have vice president 1, not very creatively named V1, and vice president 2, not creatively called V2. Maybe if we had 8 of them, we'd have a V8. But no, we're stopping there. Now, they're going to fill them from 2 different offices, right? Well, they have administrative offices in 2 manufacturing plants. Plant A has 11 offices, and Plant B has 7. I think these are supposed to say officers, but okay. All right, maybe let's change that to officers. Officers. There we go. Yes. All right. So, how many ways can these 2 positions be filled if the V1 position is to be filled from Plant A and the V2 position from Plant B? Okay. Well, we say, okay, we have the V1 and we have V2. Now, we say, well, they're going to be somewhat independent, right? Because V1 is coming from A and V2 is coming from B. So what happens is we say, do this and do that. And says you multiply. So how many ways can we pick V1? Well, Plant A, there's 11 of them. So there's 11 ways we can pick our vice president 1. And then V2 comes from Plant B, and there's 7 of them. So that's 11 times 7, right? Because there's 7 ways to pick V2. There's 11 ways to pick V1. So 11 times 7 makes 77. Okay. All right. Cool. Now, B. How many ways can the 2 positions be filled if the selection is made without regard to the plant? See, right now it says, oh, I have 2 of these vice presidents. One comes from here, the other one comes from there. And so they're somewhat independent. And so I have 2 separate pools. But what can we do? Well, what we can do is we can say, okay, we're going to make one giant pool. So there's a giant pool with 18 candidates. So one pool with 18 candidates. Okay, now that we have that, we say, all right, we need to pick our officers. So what we can do is we can pick V1, and then we can pick V2. Well, how many options do we have for V1? Well, we have 18 people to choose from. So we say, oh, well, I can pick any one of the 18 people. So that is 18. Now, I've picked V1. I can't have one person working as 2 jobs, right? So now I can't pick the same person for V2, which means there's 17 people left for me to choose from. And so I have 17 options for the second vice president. Because again, it's one giant pool. I'm no longer distinguishing plant A versus plant B. It's just one pool of 18 people. So the answer is going to be 18 times 17. And you know what? I'm going to use a calculator for that one. Why not, right? I can do that. 18 times 17 gives us 306. So there are 306 different ways to pick our vice president if we don't care about which plant they come from. And there we go. Now you might say that seems like a much larger number. Well, it should be, right? Because every way that you can have somebody from one person from plant A and the second from plant B also gets included there, but not vice versa. All right. Well, there you go. So here it's just sort of, this is multiplication in some sense. How many options do you have for the first choice times how many do you have for your second choice? And just the idea is in part A you have two separate pools. You draw one from each. In part B you have one big pool. You draw two from that one pool. All right. Number 16. From a standard 52 card deck, right? So if we have our playing cards, I don't have a deck with me. So imagine that you had a deck. You know, you've got your spades, your clubs, your hearts, your diamonds, 4 different suits. Each one has 13 cards. There's the spades and the clubs. We call those the black cards. Hearts and diamonds are called the red cards. Now we say, well, we're going to have a 3-card hand, and we have them consist entirely of black cards. Now, how many black cards are there? Well, the number of black cards total is 13 plus 13 equals 26. In other words, half of the cards are black. And the only restriction that we have is that we have to pick black cards. So, it's not like, you have to have 1 spade and 2 clubs or any other, trickery going on. So I say, okay. So from our 26 cards, we're going to choose 3 of them. This was also denoted as 26C3. So that's the answer. Except we can't put it in like that. We got to find the number. Now, how do we actually find it? Well, we have technology. No. It actually works pretty simple. So downstairs, this says 3, so we're going to multiply 3 numbers together. 3 times 2 times 1. Upstairs, start with the first number. It's 26. And again, you're going to multiply 3 numbers. But instead of starting at 3, going down to 1, you start at 26, and you just get to multiply 3 numbers. So 3 times 2 times 1, well, okay, that becomes 26, 25, 24. And at that point, you say, well, okay, what does that turn out to be? You can use a calculator and get 2,600, right? Well, let's find out. So we have 26 times 25 times 24, divide by, 3 times 2 times 1, you can do that in your head. That's, divide by 6, and see you get 2,600. Now you're probably wondering, wait, how did he get 2,600 so fast? 3 times 2 times 1 is 6. 24 divided by 6 is 4. 4 times 25 is 100. So it's 26 times 100. But you have a calculator. Don't be afraid to use it. Come on. Give yourself the best possible chance of succeeding. So the answer is there are 2,600 possible hands that have only black cards. All right, a lot of possibilities. Okay, moving on. Number 17. In a lottery game, a single ball is drawn at random from a container that contains 50. Well, I should say it contains 50 balls, right? All right, find the probability that the number drawn is even or a multiple of 7. So when it says it contains 50, well, we're thinking that it contains the numbers 1 through 50. Okay, so that's what we mean. So that should have been phrased a little bit clearer, but okay. There's a single ball drawn from random out of 1 through 50. Find the probability that the number drawn is even or a multiple of 7. Okay. Or is very telling. Okay, so we have the thing about probabilities. So probability is oftentimes it's a counting thing. So the downstairs, this is the total number of all possible outcomes. Now, for our case, we have 50 different balls, numbered 1 through 50, so there's 50 different possible outcomes. The upstairs is the number of desired outcomes. Okay, so for what's the desired outcome? Well, we are either even or a multiple of 7. Those are the desired outcomes. So let's start by counting them all, or maybe making a list. So for even, well, I don't want to write down all the numbers, but it would be like 2, 4, 6, all the way up to 50. And notice here we have 25 of these, right? Half the numbers from 1 to 50 are even. Now, what about multiple of 7? Well, that there's a little bit less of. You probably can write these down. 7, 14, 21, 28, 35, 42, and 49. So there's 1, 2, 3, 4, 5, 6, 7. So there's 7 of these. And so now we want to be even or a multiple of 7. So does that mean that we put a 32 here? And why not? Okay, so all right, you caught me there. Why not? Classic Steve. What do you have to be careful of? Right? We want or. So it could be that we actually have things in both. Notice the 14, the 28, and the 42. All of those are even. We've already got those. So what new things got added? So we had 25 numbers, plus we're going to get 1, 2, 3, 4 new things added to our list. So the number of desired outcomes, well, that's going to be 25 plus 4, or 29. So the plus 4 is, there's 4 new things that we hadn't already accounted for. So that goes here. Now it says type an integer or a decimal. Well, 29 over 50 is not an integer. It doesn't want a fraction, so we'll clear. We'll do 29 over 50, and that should be 0.58. Yep, 0.58. And so that's what we put in here, 0.58. Now, keep in mind, one thing should be true about probability. It can't be below 0, so you can't have a negative probability, and it can't be above 1, right? 1 is like 100%. And, probability is not like, oh, we're currently giving 110%. No, no, that is not how probability works. So if it's not between 0 and 1, mistakes were made. And so that's okay. Just keep that in mind, right? Want to make sure, you don't just randomly toss numbers in. You want to think about like, hey, does this make sense? Always stop and sort of question yourself. Does this feel right? Is this a reasonable answer? And if it doesn't, fix it. All right, let's keep going. We're getting close to the end, right? Well, yeah, we're almost out of time. No. That's not it. No, there's 22 questions. We're already up to 18. 5 remaining. All right, so number 18. If 2 fair dice are rolled, fair means each side comes up equally likely. And whenever they say a dice, the implied assumption is 6-sided. I'm sorry for all you D&D fans out there, but what if it's a 12-sided die? What if it's a 24-sided? No, I'm sorry. We always work with six-sided die. Okay. So, find the probability of the following result. A double, given that the sum is 8. Now, what is a double? A double means that both dice have the same value. All right. Well, let's think about that. So, in essence, this is the conditional probability, but it's a relatively simple, straightforward version of it, right? So, it essentially says find the probability that both dice are the same, given that the dice add to 8. That's the question that we were asked. And we can phrase it this way, but let's just make it simpler. So we have two pairs of dice. So the first dice can be a 1, a 2, a 3, a 4, a 5, or a 6. Now, what would the second dice have to be if I want the sum to be 8? Well, 1 plus what gives me 8? 7. Wait a second. Dice stop at 6. 2 and 6. 3 and 5, right? I'm trying to get to 8. 4 and 4. 5 and 3. 6 and 2. All right. So, what does that say? If I roll and I have a sum of 8, that says the first dice was 2, the second dice was 6, or 3, 5, or 4, 4, or 5, 3, or 6, 2. Which means there are 5 different cases we're in. And among these 5, how many of these are a double? One of them is a double. So, what's that conditional probability? Well, when we restrict the dice add to 8, our universe shrinks down to 5 possibilities. One of them has a double, so the answer is a 1 out of 5 chance. And that is the probability that we roll a double, given that the sum is 8. Right? Given that, shrink your space down to the possible situations where that occurs, and then say, okay, among those, how many gives us the right value? All right. Number 19. You draw and keep one coin, a single coin, from a bowl that contains 11 pennies, 8 dimes, and 26 quarters. What is the expected value of the game to you? And it says the expected value of the game to you is something, and it says round to 3 decimal places as needed. All right, so there's sort of an implied assumption here, and that is that we're going to just take a coin at random. Now, realistically, you probably can figure out the difference between a dime and a quarter. So it wouldn't be completely random, but let's pretend like you couldn't. So naively we say, okay, look, we've got these coins, we're just going to pick the coins at random. Okay, so first question, what's the total number of coins? Well, we have 11 plus 8 plus 26. So we can add those numbers up. 11 plus 8 is 19. 19 plus 26, 45. So there's 45 coins. So what's the probability of a penny? Well, there's 11 pennies, 45 coins. Probability of a dime? There's 8 dimes out of 45 coins. Probability of a quarter? Well, there's 26 quarters out of 45 coins. Now, here's the thing. What is this testing on us? Well, it's expected value. So we say, well, the expected value, and we tend to use x. Well, we say, look, it's how much you get times the probability of that's what you picked. So for a penny, it's 0.01 times the probability that we pick a penny, right? This is our value that we get if we pick that penny, plus the dime is 0.10 times the probability that we pick the dime, and then plus a quarter, 0.25, times the probability that we pick the quarter. So this is our computation, but we know these things, right? So this is 0.01 times 11 over 45 plus 0.10 times 8 over 45 plus 0.25 times 26 over 45. Now, we have to do it. Well, we've got to figure this number out. And for that, our calculator. Yes, our calculator is going to get a good workout here. That's okay. It can use it. 0.01 times 11 divided by 45, right? So that's the penny. Plus 0.10 times by 8 divided by 45, okay? And that's our dime. Plus 0.25 times 26 divide 45, and that's our quarter. All that equals 0.1646666. We were told to round to 3 decimal places, so 164, but then we need to round up. So the answer, the expected value, is 0.165. Now, is this reasonable? Well, our answer should be somewhere between a penny and a quarter, right? Because we can't pick something worth more than a quarter, we can't pick something worth less than a penny. So if we'd said, oh, it's worth like 84 cents, we definitely made a mistake. Okay, so actually 16.5 cents is not bad. In fact, what do we see? We see there's about half the coins are quarters. And so what does that mean? Well, if half the coins are quarters, in fact, a little bit more than half, we should expect to make about a little bit more than half a quarter. And so this is pretty reasonable. I feel pretty comfortable with this answer. And so there we go. That's our expected value. All right, see? Compute the probability of the different outcomes times how much you make in each one of those outcomes. Add it all up, and that's your expected value. Okay, number 20. The annual premium for a $10,000 insurance policy against the theft of a painting is $200. If the empirical, and empirical just says, well, this is what we expect to happen based upon, the common art thieves working in the industry today. Probability that the painting will be stolen during the year is 0.015. What is the expected return from the insurance company if you take out this insurance? In other words, how much do you expect to get back from the insurance company? So let X be the random variable for the amount of money received from the insurance company in the given year. So there's two things. And so what do we have? Well, we have that the probability that you get stolen is right here. It's 0.015. The probability of not stolen, well, what is that? Well, it's 1 subtract 0.015. And it's getting late in the test for me, so I am just going to go ahead and use my calculator to say, that's actually 0.985. So, yep, it's very unlikely that it's not stolen. Okay, but that's half the story. We also need to think about what happens. Now, if it's not stolen, how much do we get? Well, the answer is we don't get any money from insurance company, but we paid them money. So what do we do? Well, it's going to be minus 200. that's our policy payment. So we had to make the policy payment, and we had to give them $200. We got nothing back because it didn't get stolen. If it did get stolen, okay, now the story gets more interesting. What do we get? Well, we get the $10,000. Cool. But don't forget, we also had to pay for the policy. So minus the policy payment. So that is the numerical outcomes. So we can now put this together. We say, okay, so we have the expected value is what? Well, it's this. What happens if you're going to have something stolen? Well, you have that 10,000 minus the 200. Don't forget the insurance premium times the 0.015 plus, and then you have the other part. I'll go ahead and switch to a different color because I like using colors. Ha ha, ha. Okay, so the other part will be what? Well, it'll be minus 200 times 0.985. All right, and that's the computation we have to do. And once we have that number, we're good. Okay, well, back to our calculator friend here. All right, and I'll go ahead and start fresh. So we'll take 10,000. Make sure we have enough zeros there. Oops. 10,000. Let's see, where is a good place to put my calculator so you can see it? There we go. I don't want to get any glare on it. 10,000, subtract 200, and then we're going to times that by 0.015. Then we're going to add a negative 200, and we're going to times that by 0.985. And our answer is minus 50. Okay. So that is our expected outcome. In other words, on average, we lose $50. Now you might say, wait, you mean every year our expected outcome is that we're losing money from this insurance? Yes, because the insurance is taking on risk. And so that's how insurance works. The insurance company pulls risk. But that's the procedure. And there you go. There you go. I think the one thing that people can commonly make a mistake on is forgetting this minus 200. So don't forget it. Be smart. Remember it. Okay. Number 21. Find the mean for the set of group data. And as a reminder, what is the mean? Well, the mean is just another way of saying the average. And so what we're going to do is we want to find the average value. However, this data is a little bit different than sometimes the data we work with. We do have a frequency, which says here's the number of data points. But instead of having specific values, we're being given intervals. So what do you do when you have an interval? And the answer is you use the center. So if I range from 0.5 to 2.5, then what we'll do is we'll write down what's the center. Well, what's halfway between 0.5 and 2.5? Well, it's 1.5. If you're not sure, add the two numbers, divide by 2. So this isn't 0.5 subtract 2.5, by the way. So it's not negative 2. It's an interval going on. Halfway between 2.5 and 4.5 is 3.5. Halfway between 4.5 and 6.5 is 5.5. Halfway between 6.5 and 8.5 is 7.5. So we're going to use these as the values. All right, so if you're given intervals, switch to the middle points, the centers. Now, say, okay, since we have our frequency, we say, okay, we're going to take the sum of the numbers, or if you say the sum of the data, over the number of data points. So, for that, we take our frequency times the value that we're using. So it's going to be 6 times 1.5 plus 4 times 3.5 plus 9 times 5.5 plus 7 times 7.5. Now downstairs, what's the number of data? You add these numbers up. The 6 plus the 4 plus the 9 plus the 7. All right, so let's see. The downstairs I can probably do in my head. 6 plus 4 is 10. 9 plus 7 is 16. 10 plus 16 makes 26. All right. Upstairs, no, I'm not going to do that one in my head. But that's okay. So here we go. Be patient. 6 times 1.5 plus 4 times 3.5 plus 9 times 5.5 plus 7 times 7.5 equals. And the answer is 125. All right. So we have 125. We're going to divide that by 26. And we get 4. And how many decimal places? Okay, 2. So 4.8. And then we have a 0. We look to see how we round. We were going to round up. So 4.81. So 4.81. Is that reasonable? You know, that's always the same question. I always encourage people, because sometimes I look at student responses and I'm like, what? No, that was such a crazy answer. 4.81, is it kind of middle-ish? Well, that's kind of near the center. So yeah, that's feeling pretty good. It's a little bit biased towards this side, you know, with the 9 and the 7. Feeling pretty good about that. So yep, that's good. Now if it had been like 9 point something, definitely mistakes were made. So you should always think about your answers. All right, so if you have an interval, always use your centers, and then it's add up the sum of the data, frequency times the center, divide by the sum of the frequencies. Okay. Which brings us to our final problem. Feels like we just started. No, it doesn't feel like that. We've been at this for a while. But, oh, it's our last problem. Oh, maybe we should savor it for a second. Okay, that was a good second. Number 22. Earnings per share. So the earnings per share in dollars for 12 companies selected at random from the list of Fortune 500 companies are the following. And by the way, there's a word that we read just now, which is going to be important in just a moment. Selected at random. Okay, this is going to be an important phrase in just a moment. So we have these 12 data points, and then we have to do part A. Find the mean of the earnings per share, type an integer or decimal, and round to 2 decimal places. Okay, so mean, that's our average. So we're going to just, say, okay, that's like you add x1 plus x2 plus x12, because there's 12 data points, divide by 12. So we're going to add all these numbers up, then divide by 12. And so there's a lot of calculator action on this one. Okay, so clear. And 1.45, I'll go down the columns, plus 2.35. Here, just be methodical. Next column, plus 3.63, 1.04, 4.27. Go to the next column, 742, 851, 581, 541, 431, 467. Okay, if we add those up, we get 55.38, and we're going to divide that by 12. Now, I'm going to be honest with you, I haven't done this problem, so I don't know if that's the right answer. So I'm just going to add it one more time, but now I'll just go across the rows, just because I really want the points. It's like Pokemon. You want to catch them all. So I'm just going to double check my work, And it doesn't hurt. Hopefully you have plenty of time. I will say, just to foreshadow, this problem you'll probably get out and be like, ah, when you get to part B. 55.38. Good. Okay, we got the same number. Part B of this problem, I haven't even read what part B is, but I'm going to go ahead and tell you, you're going to go, it's going to take a lot of time and patience with your calculator. So I strongly encourage you, save part B to when either till the end or when you have lots of mental energy and want to do it. It's going to be the hardest thing, not because it's hard, just because it's going to require a lot of computation. Okay, so 55.38 divided by 12 equals 4.615. Oh my gosh. Oh. How do we round? Well, okay, I'll round up. So $4.62. You say, does that seem reasonable? It says, yeah, it's kind of middle-ish. We're going from like $1 up to like $8.50. A lot of things are in the 4s and 5s. 4.62, that seems like a fairly reasonable answer. Okay, so that's part A. Now the fun part. Part B. Find the standard deviation of the earnings per share. So, there's two variations of standard deviation. The question is, which one are we and how do we know? That's why I said this phrase is going to be important. Because it's the selected at random phrase, when I say there's two variations of standard deviation, there's the S and the sigma, or really what it boils down to, we're going to have a square root, we're going to have a sum. So I'm going to use our I equals 1 to n of xi minus x bar squared, and 1 over, and now here, this is the place where the two versions differ. So it's either 1 over n or 1 over n minus 1. It's 1 over n if you get all the data. It's 1 over n minus 1 if you get some of the data. Here, selected at random says we are sampling. That means we're not getting all the data, we're getting some of the data. So this becomes an n minus 1. Okay, so this is the formula. So in essence, I think this is probably the second formula that you might have to take a second to memorize. All right, we talked about one back for financial math, which is related to present value. This is the second one. All right, so for us, n equals 12. So we're going to have the square root of 1/11 times our sum, I equals 1 to 12, of xi minus, and x bar is the mean. So 4.62 squared. So here's what we're going to do. First off, we're going to compute, each one of these. We're going to subtract 4.62 and square it, and then we're going to add them all up, and we're going to do that, and then we're going to divide by 11. We're going to do that, and then we're going to take the square root of our answer, and if we do all of that, that's our standard deviation. Okay, so it's a lot of work for half a point. So that's why I say, if you have other parts of the test that you haven't done yet, do those parts first. Because this one, it's a lot of work for half a point. And we don't want to miss out on low-hanging fruit. Okay, so we're going to have to make our parentheses game be pretty strong here. Parenthesis, 1.45, right? That's our first number. Subtract our mean, 4.62, parenthesis, squared. Okay, so that's the first number. Plus, next number, 2.35, subtract 4.62 squared. All right, I'm going to keep track. So we've done 1, 2, plus 6.51, subtract 4.62 squared. Okay, we've got that one, plus 3.63, subtract 4.62 squared. Okay, we got that one, plus 1.04, subtract 4.62, parenthesis, squared. Got that one, plus parenthesis, 4.27, subtract 4.62, parenthesis, squared. Okay, we got that one, plus, open parenthesis, 7.42, minus 4.62, parenthesis, squared. Oh no! Oh no! We can only put in so many things. Okay, all right. Equals. That's halfway, huh? Okay, so if at the halfway point we have 32.6929. Still have the other half to do. All right. Wow. Okay, 7.42. Subtract 4.62 squared. I didn't know that my calculator had a limit. Oh, calculator. I still like you, but my goodness. And it's okay if you're like frustrated. It's like, wait, really? Really? And yeah, I get you. I get you. You know, the truth is that oftentimes you might feel like this would be something a computer could do very easily. You are correct. And that's why, we have computers to do these kinds of computations. It maybe makes you appreciate how good it is to have. Okay. I will say on a side note here, when they write down there's an estimate that they say, how long do we think it'll take people to do these problems? And it gives a ridiculously low number for this. Why? Because it will say, oh, we think someone will have technology. Okay, like a spreadsheet. And a spreadsheet can do this automatically. All right, so we have 25.1109. Add that to 32.6929, which was previously, and we're getting 57.8038. Okay, so that's this piece right here. Now, because I really do want to get that half a point, I'm going to do it a second time. And I understand if you want to fast forward a minute or two or 3 or 4, go ahead. But this is one of those things where it's just like, it's so easy to make a mistake. So I'm going to now do going across. And we get 57.8038. Okay, so yes, we did it right the first time. Oh, okay, good. We did the computation twice. We got the same thing twice. So, woohoo! Now we can be confident about our answer. What do we need to do with this? We need to divide this by 11. Okay, so after we divide by 11, we have the square root of 5.25489, ... Now, we only need to 2 decimal places, so if you do like a couple extra decimal places, when you take the square root, you'll be good to go. And so we want to take the square root, and we have a square root here, and so we'll have the square root, and I'll just type this number in, 5.25489. And we get our answer, 2.29. We need to round to 2 decimal places, so we're going to just say 2.29. Is it reasonable? Well, it shouldn't be too big, right? All our data roams between 1 and 8, roughly speaking. So if we had a huge number, that wouldn't make sense, because the huge number would say, oh, we're going outside of our range. And so usually a standard deviation will keep, roughly 2/3 of the data is within one standard deviation. And it shouldn't be super small. A super small number says, oh, everything's near the middle. This is a good, reasonable number. And so there you go. Our last problem. We made it through. And this one definitely does take a few extra minutes, so pace yourself. Take your time. I know it's frustrating, and I know you're just going to be like, why are we doing this? Be patient. You can do it. You can do it. And you can do the whole test. You've been working on it this whole semester. Finish it. Do well. Pass the class. Do what it takes, and you can succeed. Put in your time. It'll pay off. So this is our final time together. And, thank you for being with me. Thank you for spending time and trusting me. I'm glad that you're making progress, and I'm glad you're moving forward. I wish you all the best. I hope you succeed, not just in this class, but in all those classes yet to come and in life. I wish you the best. Good luck. Thank you again.